We just want to look at trigonometric ratios really quick and then move on. Here we know sine theta equal to opposite over hypotenuse of this triangle, and the opposite refers to the opposite of whatever angle we're talking about. So if this is the angle we're talking about, theta here, then opposite is the A and the hypotenuse is C. If we're talking about this angle here, then the opposite is B and the hypotenuse is C. So when we're looking at the sine theta, the sine theta is this. Then cosec, sometimes written as CS. See, this is short form cosec theta is 1 over sine theta. So you just invert that. Then cos theta is adjacent of hypotenuse. That's CAH. They sometimes use this to remember, SOHCAHTOA to remember. And then the inverse of that sec is the inverse of that, and then you have cot as the inverse of tan, and that's it. Then one thing about angles is that if you have sine theta, then sine theta will be equal to cos 90 degrees minus theta. So remember this stuff. For instance, if I say sine 150 sine 150 is equal to cos 90 minus 150. Yes, to be negative, minus 150. You could try that. So that's cos minus 60, and cos minus 60 is same thing as sine 150. So just remember that. Then for cos theta is sine 90 degrees minus theta. We call this complementary angles. Now if sine is less than A and cos is less than B, then M is less than A plus M is less than B equal to 90 degrees. We'll see that while we're solving more questions inside. Alright, so we have trig identities, quite important. Tan theta sine theta over cos theta, very important. That's because tan is opposite over adjacent and sine is opposite over hypotenuse. If you are dividing it by cos, you'll be doing times hypotenuse over adjacent, and that's dividing by cos theta. Cos theta is adjacent to hypotenuse, so when you change it to times, you flip it, hypotenuse over adjacent, you cut this h and this h, and you get opposite over adjacent, which is the same thing as tan theta here. And then we also have sine square theta plus cos square theta equal to 1. That's a very important function. Sine square theta plus cos square theta. You may wonder, how would I be able to square sine theta? How would I be able to square that? Well, you can easily square that by let's say they give you theta. Okay, let's say they give you 20. The first thing to do is to first find the sine of 20. What is sine 20? Okay, when you find out what is sine 20, and you find sine 20, then square it, square your answer. That's how you get that. That's what I mean by sine square theta. First get sine 20 and square whatever you get. That's how you get square. For instance, look at this. If sine theta is equal to 2 over 3, sine theta is equal to 2 over 3. So you now square that. Just as if sine 20, like what I just mentioned, you do sine 20, then you square that. Okay, so let's move on to some questions right here. Said the triangle shown below, AB equal to BC equal to 10 and AC equal to 12. What's the value of cos theta? Now if these are equivalent in nature, if these are equivalent, these are equal, all you need to do is divide this into 2. If you divide this into 2, whatever angle is here will be the same angle here. And if that's the case and you're dividing it into 2, that means whatever side here is the same side here. That's because their base angles are equal. So here is 6 and here will be 6. So what's value of cos theta? This place is a 90 degrees, so this is now a right angle. You could have not done it in anything about it if you did not make it a right angle. So that's it. So now what is the value of cos theta? Whatever theta is here is equal to opposite here. This is less opposite. This is the hypotenuse and this is the adjacent. Now remember that cos theta equal to what? Cos theta is equal to adjacent over hypotenuse. So you have 6 over 10, and 6 over 10 is same thing as 0.6. So cos theta then is adjacent over hypotenuse 6 over 10, and that's your answer, 0.6. Then let's look at the next one here. Question number 2. What is the value of sine theta in that same question? You see, now remember what I told you about this arrow here. This arrow here shows that your questions, everything under it, until they show you the other arrow that points upward, then you know that whatever you are doing comes from this, and that's just a fast way of remembering, just in case you forgot. Alright, let's look at question number 2. What is value of sine theta? Sine theta is what? Opposite over hypotenuse there, and the opposite that we did not get the opposite in that thing. We did not get the opposite, so all you need to do to get the opposite, you can use Pythagoras to get the opposite. You have 6 square, which is 36, and 10 square. So you have 10 square minus 36. That's 100 minus 36. 100 minus 36 will give you 64. Square root of 64 will give you 8. So here is 8. Remember Pythagoras theorem. So we have what is the sine of theta? Opposite over hypotenuse. That is 8 over 10, and that's 0.8. So let's move to question number 3, and let's see if there's any more challenge there. What's the value of tan theta? Tan theta is just what? Tan theta is opposite over adjacent, which is 8 over 6. There, 8 over 6 can be 8 over 6 there could be reduced to 4 over 3. So that's your answer. If you look at this one, question number 4, in figures above, y is less than x less than 90 and cos x equal to sine y. Okay, so here you have y being less than x, which is being less than 90. So none of them are up to 90, and cos x equal to sine y. X equal to 3a minus 14 and y equal to 15 minus a. Now remember this complementary angles here. Remember these complementary angles here. We said sine a cos sine at the angle A cos the angle B, then m of the angle A plus m of B is equal to 90 degrees. So what we're gonna do, now what is that m? So I brought them side by side and let's work on them. So first of all, sine of this, that's this is cos x and sine y. You see both of them are equal. Cos x and sine y are equal. Then m of a, which is, so let's solve this. 3a minus 14, this will give 3a minus 14 plus 15 minus a is equal to 90 degrees. So asking for the value of a. So let's go. 3a minus a is 2a minus 14 plus 15 is minus is plus 36 is equal to 90. So we have 2a is equal to 90 minus 36. 90 minus 36 is equal to 54, and a is equal to 54 over 2, and that will give you 27. So we have 27 degrees there. 27, not 27. So that's our answer. So now you know how to solve this. Let's return. So now we have this, given the right triangle ABC above, which of the following is equal to AC? Okay, A over C. So all you need to do, remember, is that when it comes to this, we're looking for A over C. That is opposite over hypotenuse, opposite over hypotenuse of this angle A. Of course, sine of the angle sine A is equal to opposite, which is this A over hypotenuse C. So that's sine A. Now let's check whether any other will match A over C. Tan A, no, but what about cos B? Yes, cos B is adjacent over hypotenuse. A over C, this is adjacent over hypotenuse, so we have I and I only, and I only. But tan A is not. Tan A is opposite over adjacent, which is this and this B. So let's move to number 6. So here I want to look at what the radian is. I once told you that in order to convert from degrees to radians, all you need to do is multiply that your degree, any degree that you want, okay, multiply it by pi over 180. Multiply it by pi over 180 to convert from degrees to radians. So just in case you want to do your thing in degrees, but maybe they give you radians, just simply convert it. Okay, and the 1 degree is equal to pi over 180. So imagine if you want to get 90 degrees, just simply do 90 times pi over 180. Now same goes for if you want to do radians. Okay, if 1 radian is equal to 180 degrees over pi, if you want to get 5 radians, okay, if you want to move like let's say you want to move 360 degrees, or let's say 150 degrees, okay, let's say you want to move 150 degrees, all you need to do is to 150 times pi over 180. Your answer, 150 times pi over 180, your answer will come out in radians. Then if you want to move the radians to degree, all you need to do is to multiply it by 180 over pi. So for instance, if you want to make 3 radians if you want to move 3 radians to degrees, just simply do 3 times 180 over pi. That's it. So there's something that we call coterminal angles. When it comes to coterminal angles, we're talking about angles that are equal. So this place, when we're looking at an angle, for instance, positive angles is starting from this position here, starting from this plane, this x plane here, starting from here. Anything you count this way is positive. Then anything you count from this way is negative. Okay, and when it comes to angles, we actually have 4 of those quadrants, and in all those 4 quadrants we use ASTC to remember that anything, all of them are positive here. The 3 trig functions, sine, cos, and tan, are actually are all positive in the first quadrant. The second quadrant, sine is positive. The third quadrant, only tan, and the last quadrant, only cos is positive. All the others except sine, tan, and cos are negative in all these quadrants. So all we're talking about is that sometimes some of them are equal in different quadrants. For instance, in this angle here, if let's say cos 300, for instance, cos 300 have a sine value. Since cos is positive here, it has a sine value that's also positive at this point here, and we can get that value by looking at what the angle is at this point here. Whatever the angle is here is similar to whatever the angle is at this point. Okay, so let's see if this is 300 here. That's from 270 to 300. We have about 30. We have about 30 degrees here. 30 degrees here, and we have about 30. So the distance between this place is actually 30 degrees. But what is the distance over here? So if we have this 30 here, remember that sine and cos are related by 90 degrees minus theta. 90 degrees minus theta. So this is 30 degrees here. 90 degrees minus theta will give you 60 degrees. So now add that to 90 degrees, you have 150. So if you check sine 30 on this first quadrant, it will give you the same thing as 300. If you check sine 150, that's sine 90 plus 60, which is 150. You're also going to get sine of you're going to get something equivalent to cos 300. So this is it. Sine 150 is equal to cos 300. You could look that up. And we just explained that in order for you to get that, just check the angle here from 270 to 300. You see it's 30 degrees. Now whatever that angle is, it represents this angle here, 30 degrees. Now opposing angles are equal. Then the actual angle, what sine is actually this plus 90 degrees here, and that's it. Sine 90 degrees plus whatever is here. That's it. Now another thing you need to also realize is that actually these angles, when it comes to a unit circle, like this, that quadrant, let's use I think we should use a unit circle to illustrate. Let's use this unit circle here to illustrate what we mean. Now if you notice, at this point this is 1. Okay, this is a unit circle. 1 1. At this point you have 1. At this point you also have 1. But this here is negative 1, and here is 1. But for the y-axis, this point is actually 0, and for this point it's actually 0 too. Okay, so when you are looking at this unit circle here, when it gets to this point, you see that 90 sine 90, sine 90. Okay, you see sine 90 is 1 at this point here. Then if you go downwards, this is 270. That's why you see sine 270 is actually minus 1. Why? Because this place is minus 1 on the y-axis, for the y-axis. Then if you look at sine 180, you see is 0 at this point, and sine 360 is also is also 0. So you see, you can use a unit circle to explain what we mean. But for the cosine, you see cos 90 is equal to 0 actually. So, and then when you get to cos 0, you actually get 1. So you see that the cosine actually, for it starts here 0 degree. It actually starts here. So and this, when it gets to this point, you see cos 180, you get minus 1. See, when you move from here, cos 180, this is 0. From 0 to 180 is minus 1. So you see that your value, and if you check cos 90 is actually 0 at this point here, while cos 0 is 1 here. So your cos is actually starting from this point here. Then that's it between sine and cos. So just remember, and the difference between both of them, see, is 90 degrees. See, it's 90 degrees. So try to remember that simple trick. If you remember that simple trick, you'll solve many questions. Alright, let's go into question number 1. We're already stepping on question number 1, so let's try it. Question number 1 is like in the xy plane above, the center of the circle and the measure of POQ is k pi radians. What is the value of k? So we have 1,1 there, and they say the value there is k pi radians. Okay, the value of POQ, this is POQ, the angle in here is k pi radians. Now it's asking what is the value of k. Now if this place is p equal to 1,1, that means here is 1, so it's a unit circle, and then here is also here is 1, here is 1. For it to be 1,1, if you drag this line like this, here is 1. You see, 1,1, that is the location, 1,1. So if they ask what is the value of k, what's the value of k? Because POQ is k pi radian, this angle theta here. So how will we get that? How will we get that? Knowing that this is 1 and the height here is 1. The height of this is 1 and this is 1. So we have a triangle of 1, 1, 1 and 1. Now we have a triangle that way, and we're looking for the angle theta here. Now if you look at this, remember theta equal to opposite over hypotenuse. Okay, that's theta sine opposite over hypotenuse. So sine theta, that's the angle equal to opposite, which is 1 over hypotenuse. How will we get the hypotenuse here? From 1 square plus 1 square, the square root of that. 1 square plus 1 square is 2, so it's square root of 2. So we have root 2. So theta is equal to the inverse of 1 over root 2. So you have 45. The angle there is 45 degrees. 45 degrees. So actually, if you know your trig functions very well, you would have just known that this is 1 over root 2. But that doesn't matter anyway. So now you just that this 1 over root 2 is 45. So theta is 45 degrees. But that doesn't matter here now. But since you now know it's 45 degrees. Anyway, so now for 45 degrees, 45 degrees is equal to k pi radians. K pi radians. When you know that to convert from radians, degrees to radians, is to do 45 times whatever they give to you, whatever, like times 180 over pi, a pi over 180. 45 times pi over 180. That's how you convert from radians. So k pi radians is equal to 45 times pi over 180. What is 45 over 180? That's what k is. Look at it. K is actually 45 over 180. That's just what they want you to do. So 45 divided by 180, if you reduce that, you'll be having 1 over 4. So B is your answer. And that makes some sense. That makes some sense. Because actually, if you look at a circle is 2 pi radians. Okay, a circle is 2 pi radians, and now this is half of this is half. So actually this is 1 over 8. 1 over 8 of the entire circle. 1 over 8 of the entire circle. 1 over 8 times 2 pi. Okay, 1 over 8 over times 2 pi will give you 1 over 4. Okay, 1 over 4 pi, and that's what this k pi radians is. If you were very fast, you would have just done it that way, knowing that this is 1 over 4, 1 over 8 of the entire circle times 2 pi, because 360 degrees is 2 pi radians. So you can do it with any of the method I just showed you. Using this 1 over 8 is when you are sure that this thing is actually half of this circle, knowing that it's half of this circle. Okay, if you don't know that it's half, then you won't be able to do that. half of this quadrant, rather half of this quadrant. If you don't know that it's half, then you'll not be able to use that 1/8 pi. All right, let's move on to the next one. So which of the following is equal to cos pi/8? Are we still using the first one? No, we're not using the first one. There's no arrow. Remember, if there's no arrow, that means it doesn't follow. So which of the following is equal to cos pi/8? Okay, now cos pi/8 is same thing as saying, pi/8 is what is equal to cos pi/8. Now what you do is, remember, sine theta is equal to cos 90 degrees minus theta. Okay, from this angle cosine theta equal to cos 90 degrees minus theta, and cos theta is equal to sine 90 degrees minus theta. So you see that that's on the first quadrant, and you know that pi/8 is happening on the first quadrant. It's happening in the first quadrant because if you divide, pi is 180. If you divide it by 8, you're dividing this stuff by 8 places, up to 1, 2, 3, 4, 8 places. Divided by 8 different places. Divide it into 8 different places. 4, 5, 6, 7, about 8 places. And one of them, theta, that cos is one of that small places there. So cos theta is equal to sine 90 minus theta. So just replace theta with pi/8. So pi/8 equal to sine 90. What is 90 degrees? Remember that pi is 180. If pi is 180, then what is 90 degrees? 90 degrees would be, 90 degrees is pi/2. So we're looking at sine pi/2 minus what? pi/8. Oh, this give you let's see that. Let's of 208 is 8, or let's just use the same method. Pi/2, multiply it up and down by 4, up and down by 4, so that it will give 8, then minus pi/8, and this will give you 4pi/8 minus pi/8. Yeah, you can see the answer. 4pi minus pi is 3pi/8. So you have sine 3pi/8. So that's your answer there, C. Okay, so let's look at this one here. In the xy plane above, theta is the center of the circle, and the measures of AOD is pi/3. AOD is pi/3. So where is AOD? AOD is this angle here. Okay, pi/3. The radius of circle O is 6. So from here to here is 6. Okay, this is the radius. It is the length of AD. So they're asking for this side. So you can remember, this is opposite over hypotenuse. So you're using sine opposite over hypotenuse. So sine that angle AOD is pi/3. That's sine pi/3 is equal to opposite over hypotenuse, which is 6 over opposite is, we don't know opposite, sorry. We don't know the opposite over hypotenuse. That's the length. AD is the opposite over the hypotenuse 6. So what's sine pi/3? Well, sine pi/3 is not too hard to think of. No, pi/3 is actually 180 divided by 3. That's 180 divided by 3. 180 divided by 3, this is 60, so sine 60. So why I say sine 60? What is sine 60? I hope you could remember what I'm going to show you now. You're going to write out this and keep it safe. Okay, So if I have a unit triangle of side 2 1 1, which is the entire thing is 2, this is an equilateral triangle, and then I have an angle here. I have, this is, let's say this is 60 degrees and this is 30 degrees. Of course this is 90 degrees because it's a right angle triangle. Then what we are saying is that to get some of the trig functions here, sine theta, that's sine 60 is equal to opposite. What's the opposite? This is the opposite, and actually this opposite side is 2 plus 1, 2 square, that's 4, minus 1 square, actually that's 3, and that's the square root of 3. So we have the opposite, which goes sine 60 is actually root 3 over, what's the hypotenuse 2, root 3 over 2. Sine 60 equal to root 3 over 2. I want to play around with this, get sine 30, get cos 30, get tan 30, and see all the trig functions that will come out from this. So we have root 3 over 2, because sine pi over 3 is root 3 over 2. Okay, if it's a calculator question, you can easily solve it without even knowing much of these trig functions. So we have root 3 over 2 equal to unknown over 6. Just carry the 6 and multiply this, carry 6 to the other side. We have the unknown is equal to, that's AD, equal to 6 root 3 over 2, and that's 3 root 3, which is D, because the 2 will cancel the 6, and that's it. So it's 3 root 3. Alright, let's go forward, solve the next, last one, number 4. They're saying the figure below, what is the value of cos angle AOD? You see, this is 3,4. So when I say 3,4, this height here, it's not up to that exact position, but this point is 3,4. So you have 4 here, you have 4 here, the position of 4 here, and you have the position 3. So OD is actually 3. Then this place here, height here, from A to D is actually 3. Okay, so what is the value of cos AOD? AOD, so this is the angle here, AOD, this is the angle. We need the angle. So what is the angle? Cos is equal to opposite over hypotenuse, adjacent of hypotenuse. That's 4, yeah, it's 4, sorry, yeah, it's 4, oh, sorry, yeah, it's 4. I flipped that. Yeah, it's actually 4, the y, and then here is 3. So we don't know what this place is, but we can use our Pythagoras to get that real quick. So that's 4 square plus 3 square, that's 16 plus 9. 16 plus 9 is 25, so here is 5. So if that place is 5 there, so we have 5, 4, 3. That's a Pythagoras triple, Pythagorean triple, 5, 4, 3. So what is the value of cos AOD? Cos equal to cos AOD is equal to adjacent, which is 3, over hypotenuse, which is 5. Adjacent over hypotenuse, so we have 3 or 5 there. Okay, so quite simple. Let's move on to the next one. Watch the next video more on